So a major problem that broken piston rings can cause is vertical scoring on your pistons or in your cylinders. Luckily, I think these pistons are going to be okay, but we'll let the machine shop be the judge of that. But you can see that there's some light scoring on those pistons. In the cylinders, you can definitely see some vertical scoring there. Hopefully that view is okay. Check this one out. The next one. A lot of these cylinders got vertically scored, and that's definitely not something you want to see. But what we're really looking for to see if these cylinders are savable is this little edge up here. You can see how it's discolored at the top right there. That's where the piston ring comes up, and it stops right there because there's a little hat on the piston that comes up a little bit further to the top of that cylinder. Now, if there's an edge right there, like a burr, which on any engine over like 70,000 miles or even over 50,000 miles probably has a little bit of an edge on there, what you need to do is bore the cylinder so that you can make the whole cylinder from bottom to top all the way up past that edge the exact same size. But since I rebuilt this engine last year, and or a couple years ago, there's not much of a lip right there, if at all. And so it's very possible that I can get away with just re-honing these cylinders. And what honing means is basically a good example on this cylinder. You can see those little crosshatch marks, hopefully. Basically, scratches going this way and scratches going this way. And those crosshatches are basically a way for the rings to seat and for it to stop oil from getting past the rings or blow by. And when you hone a cylinder, you're basically putting those scratches back into it so that you can replace the piston rings and then seat the new rings. So hopefully I can get away with just re-honing these cylinders. I shouldn't have to bore it. Some people think that boring is good because you're opening up that cylinder, which causes more air, which means you can add more fuel and make more power. That is half true, but a big reason why you don't want to continue to keep boring the cylinders or go too big is that this wall right here will get too thin and it can become really brittle or weak, and it can even start to crack. So hopefully I can just get away with rehoning these cylinders and call it a day. The next thing we want to do at the machine shop is something called decking the block. What that means is this surface right here needs to be perfectly straight. If it's not perfectly flat, then some pistons may come up in the cylinder higher than others, and it will run inconsistently because some of the cylinders will create more compression and have more power, or they'll make more torque in that cylinder than the other cylinders. And the more consistently, the more even you can get your cylinders to run next to each other, the better. And so when you take your block to a machine shop, one thing you want to have them do is something called a true deck. What that means is basically with a normal decking process, they only use one piston to do the decking process. But with the true deck, they put a cylinder in, let's say, cylinders 1 and 3 and 5 and 7. And then what they do is they put both of those pistons at the very top of the cylinder, and then they measure the distance between the top of the piston to the top of the block, and then they machine that straight. If you have only one piston in it, it's possible that straight line will curve down this way, or maybe go up this way. So it will cause an inconsistency. But with true decking and you use two pistons, it's way more accurate and it's more even across the whole length of the block. Another thing they'll check at the machine shop are these little bores of the lifters. They'll just make sure all those are smooth and straight. The machine shop's also going to replace these cam bearings. Now, you can do these yourself, but you have to buy a very expensive tool, and there's a long process to replace these. And in my machine shop, they only charge like $20 to replace them. The bearings are super cheap. I highly recommend just having a professional do it. Big reason why, you'll see these little oil holes in here, and every single bearing is different, and they have to be clocked to a certain position, otherwise that oil won't be able to feed through. And if that's not perfect, then your engine's going to go bye-bye. So I highly recommend just having a machine shop do that for you, just so that nothing can go wrong and you can be sure that everything was installed correctly. One thing that you can visually look for on the block once you have it disassembled are any cracks or anything, or scratches anywhere, or major like burrs or damages. But with the cracking, there's going to be certain cracks that you may not be able to see. So when you take it to your machine shop, they're actually going to coat the cylinders and the main caps. And anywhere that there's moving parts, they're going to coat it with a powder, and that powder makes all the cracking visually stand out very well so that they can ensure that your block is in good shape and it can be remachined. But just to save yourself a little bit of time, if you can see any cracking on your own without even taking it to a machine shop or without using any of that powder, then you can save yourself a lot of time from even trying to rebuild that engine. All right, let's flip it around and take a look at the bottom end. A couple of things that the machine shop's going to do on the bottom end of the engine to make sure that the rotating assembly is all in good condition. They're going to take your crankshaft and they're going to install the rods and pistons on it, and they put it on a machine and they're going to spin it to make sure that everything is balanced properly. Now with the crankshaft, you have your main journals where the main caps hold it. That's basically the center point of the crankshaft that the crankshaft spins on. And then you have these offset pins. They're just called pins. That's where your connecting rods go. And then you have these weird things that stick out to the side. These are counterweights. Basically, there's these holes in the crankshaft, and they can either drill out those holes or add weld slag, or they can add weld into those holes to add or remove weight from the crankshaft to properly balance it out so that there are no vibrations. And then obviously you have a harmonic balancer to help you out with that too. Once they have the rotating assembly all balanced out and good, they're going to put all the main caps on like I have them on here. And then if you look down through the center, it creates a perfect hole where the center line of the crank goes through. What they do is they run a hone machine through that whole center line to make sure that it is perfectly straight, and that's called a line hone. Now earlier when I said that it's very important that you put your main caps back on the exact same spot they came off and in the same direction that they came off, the reason why is imagine if they did the line hone and it wasn't perfectly straight. Now obviously it is perfectly straight, but to a machine shop standpoint, it could be like a millionth of an inch off, and if that isn't perfectly straight and you start mix matching bearings, then the cap isn't going to match up to the block the way that they machined it, and then your crankshaft will get damaged because it's not going to be a perfectly straight hole. When it comes to machine work, you want to really make sure that you don't chump out on machine work. Don't go the cheaper option, go the quality option. It's always better to take more time, to spend the more money, and get the proper machine work done than to waste all of the money that you spend on getting bad machine work done and having everything fail. Ask me how I know. We got some goodies. This is always like Christmas when you get a box from Summit Racing. All right, we all know it's no fun to get all your parts back from the machine shop and have nothing to do. So if you guys want to prepare and buy all the gaskets and tools necessary for the reassembly process, I'll just walk you through like some of the things that I bought to prepare. So first of all, gaskets. Super, super important. Don't cheap out on gaskets. Get either OEM ones, or I like to go with Felpro. They always have really good stuff. I've never had any problems or leaks with any of these. So you're going to need a rear main seal. Part number BS40520. And it comes with the little gasket that goes on the back of the rear main seal. The timing cover seal. That one's part number 101-28316. If you want to just pause the video on any of these, you can. And that's going to be this lower front main seal here. The next one that you want is this distributor shaft seal as well. This one's part number ADO-D3995A. And then this top seal for the water pump drive seal. This one's part number NAL-10217886. And then it's also not a bad idea to replace that little O-ring on that seal there. That one's part number NAL-12553792. Next one is the intake manifold gaskets. I had mine ported out, but the stock gaskets, just for stock porting, will work just fine. This one's part number MS95580. Came with the gasket for the throttle body. I actually have an aftermarket throttle body, so I won't be using this gasket, and mine's ported out to 58 millimeters. So I won't be using that one. And then we use the right stuff instead of these little cork gaskets. They're in there somewhere, but these little cork gaskets, they go along that China wall on the block. Those cork gaskets tend to squish out, especially if you've had the block milled, or if you've had the heads milled down at all, had any head work done. They're really likely to just squish out, so I like to use this right stuff instead, so that I can kind of make my own gasket with that. And then head gaskets. This is super important and specific to your application, because when you tighten down your heads, this gasket is a certain thickness and it's actually going to crush down. And the thicker the gasket, the more volume there will be in your combustion chamber and the lower your compression will be. So if you're running like boosted applications, you're going to want to get a thicker head gasket. For me, it's an NA build, so I actually just got stock head gaskets. These rings are big enough for the overbore size. The rings are 4.125 inches. With Felpro gaskets, you really want that fire ring to be far away from the cylinder head. Unless you run like a high performance head gasket, then you can get something that's like more accurate to close up that gap. This one's part number, it was just Felpro 1074. This one's thickness is 0.039 and the fire ring is already at the crushed thickness. It's a pre-flattened copper wire ring. Head gaskets are super important to buy for an LT1 specifically because LT1s have reverse cooling where the coolant goes through the heads and then into the block rather than from the block to the heads like small block Chevys. So if you buy a regular head gasket for a small block Chevy, it's not going to work. Obviously, you're going to need 2 of those. And then the last thing that I got was an oil pan gasket, part number OS34500R. This one also comes with that little oil filter adapter gasket. So you won't have to search around for one of those. It'll come in with this one. You're also going to need some rod bearings. I just got the Molly part number CB663P-10. But get those from your machine shop. Make sure that they're specific to how your bearings are ground. Because it depends on how many times your crankshaft has been reground. It depends on a lot of different factors, so you need to make sure that you're getting the right size bearings. And then same for the main bearings. Same, I went with the Molly. These ones are part number MS909P-10. And then I got some Hastings Molly rings. These are great. These were just recommended by my machine shop, and they have already gapped the rings to the proper size. It's always good to have them do that. If not, then you need to buy a machinist file and a piston ring grinding tool. And basically you have to gap the rings. I'll show you how to check the gap of the rings so that you'll know if they're the right size or not. Because it's always good to double check, even if they've already done them. I'm going to double check all my rings to make sure that they're at the right gap. And then if they're not at the right gap, then you need to have a couple of specialty tools to grind the rings down and then file the burrs off of them to make sure that they're in good condition. And then these are the core plugs that you're going to need to replace all the expansion plugs with in the block. There's going to be the oil galley plugs in there. There's going to be some of the main plugs. There's a big plug for the cam. You're going to need all of those. Fortunately, mine are already installed because, like I said, I've already done these from the previous rebuild, and they were still in good condition. They didn't need to clean all that out in there. So I just went ahead and left all of those in there. And mine are all good to go. So all I need to do is just install these oil galley plugs and I'll be ready to go. Then you're also going to want some assembly lube. I think any brand will work fine, but Lucas is a great brand, so I trust what they have. And then you're going to want some rifle brushes to clean out the crankshaft with. I'll show you how to do that in a little bit. Then I also bought some of this, the Right Stuff, Permatex The Right Stuff black gasket maker. This will be used on the intake manifold and some other various parts that I'll show you along the assembly. This stuff works really good for oil resistance. And then this Permatex high-tack gasket sealant. We're going to use this on some very specific parts too. I've just heard from other engine builders and from my experience that this stuff really helps to make sure that you don't have any leaks. And then for the last part that I bought were these head bolts. This is part number 1343601. I think ARP is amazing, whether you're doing boosted applications or you're doing something a lot more higher horsepower. ARP is always a good way to go. I just went with the bolts for more of just like an upgraded bolts rather than studs. But if you're doing any kind of boosted application, you'll definitely want to do studs that are a lot stronger. So on to the tools that you're going to need. These snap ring pliers, I just had these laying around. I didn't actually buy these recently, but you're definitely going to want these if you have floating pistons, because you may need to remove the wrist pin from the piston to separate the piston from the connecting rods. And if that's the case, you're going to need to remove the snap ring from the pistons. This is a rod journal protector tool. You'll need this to install your pistons. The next thing is this engine oil priming tool. Before you put the intake manifold on, I'll show you how to use this, but you basically use this to pump the oil through the engine before installing it into the car, just so that there's proper lubrication throughout the entire engine so that it's ready to start once you get the engine installed into the car. Then I also got some piston ring expanding pliers. These are going to be great to put on the 2 compression rings. They can be really brittle, so you really need to use one of these tools, because if you twist or try to bend or expand those rings with your fingers, or you try to stretch them out, it's possible that they could crack and then they're going to break. Another precautionary tool putting in your pistons is going to be a piston ring compressor tool. This one's a cone shape, so you can't actually see it, but this ring actually gets smaller and smaller. So you'll set this on the block and then drive the piston in, and it's going to compress the rings as it goes into the block. Unfortunately, I bought the wrong one, so I'll probably just run to AutoZone and grab one. This is for a 30 over bore. Mine's only 20 over bore. So if I were to use this, it's really likely that those piston rings wouldn't be compressed enough trying to go into the block, and it would crack the rings. Onto the more fancy tools, I got a micrometer gauge. You can order all this stuff off of Summit Racing, or probably a lot of the parts stores that you have just locally have them. You might even be able to rent some of these. But I like to order from Summit. This all got here in one day. This is a micrometer caliper, and basically it's going to be used to measure all the clearances of the crankshaft and the bearings prior to installation, because you really never know what the exact measurement is, and machine shops should be doing a good job, but apparently the last machine shop that I took my engine parts to didn't measure everything correctly. I found out that at the machine shop they told me that the bearings on the crankshaft were actually too tight, so the clearances were too tight. It wasn't measured properly. If I had a little bit bigger of a bearing, my engine could be totally fine today, but just because I didn't spend the extra couple, like $50 or so on one of these tools, I'm going through all the headache of buying all this stuff and rebuilding my engine just because I didn't measure a couple of extra things. So it's totally worth it to go the extra mile, buy the nice tools, buy the tools to double check all the work that your machine shop does so that you can put your engine together knowing that it's going to last another 150, 200,000 miles. Another tool that you can use instead of one of these fancy calipers to measure your bearing clearances is some plasti gauge. I'll show you how to use this stuff too. It's just a little bit cheaper way to do it. I just like to have the precision measuring tools to make sure that everything is perfect. But this plasti gauge will work great too to measure your bearing clearances. You're going to want to get one of these thread restore kits from an auto parts store. You can buy them or rent them. They're super cheap. There's just going to be a couple of different threads that we're going to want to chase out for better sealing, for better torquing. There's just different kind of various parts that you're going to want to clean out and make sure that the threads are perfect so that you can even torque load through. The last thing that I bought is this dial indicator. This tool is going to be used to measure our crankshaft end play. So the crankshaft, once it's installed, there's a thrust bearing to keep it from moving too far forward and back, but there is going to be a little bit of play, and we're going to use this dial indicator to make sure that there's the right amount of play so that things aren't loose or too tight. You're also going to need one of these if you're planning on degreeing your camshaft. This is used to find exact top dead center on one of your cylinders so that you can be sure that you're degreeing your cam properly, because the piston will get to the top of the cylinder and it's going to have some dwell time basically where the piston's coming up and the connecting rod is transferring over the top, and during that transfer time that piston dwells at the top of the cylinder. So if you don't know that the piston's at exact top dead center and you try to degree your cam, then it's going to be way off. So you need to make sure that you have one of these dial indicators to make sure that the piston is at the proper top dead center. And that should be all the tools that you're going to need to get started on your rebuild. So let's get going.